All right, so let's see how far we can get along with this. We still have about 18 some odd slides. Is it 18, 17? Um, so we're talking about parabolas. Another way, actually, this is the way we've been doing it. Um, Again, the easiest way to think about it is the ones we're used to are vertical. So it's going to have that x squared somewhere in there. And horizontal is backwards from what we're used to. So it's going to have that y squared. All right. I mean, we've covered this pretty well, especially in the first video. It felt a little easier in the second video, but we can tell that we're always going to add the p, whatever p is, to get the focus, and subtract to get the directrix. So let's move on from here. So here they're just doing examples. So if you want to see a precise example besides the one we've been working on, this is a good way to kind of see how we can figure out what this curve is. Um, I kind of like it. It's interesting to see that the y squared is the square root of it. However, in order to have this bottom part, you have to have the negative square root of it. All right, so let's see here. So directrix and everything. We've done this before. We can plug it in. You can figure out what the p is by calculating the distance from here to here. It's actually not that hard because what we're doing is just looking at the y value, comparing it to this y value. It's like, oh, you need 1 to go from here to here, and then 2 more here. So your p ends up being a 3. And then you can plug in your k, and that gives you a general formula that you can use for a parabola right here. Uh, I guess standard form's a little more accurate. And if you don't like having fractions, you can always, in this case, you can multiply this by 12. Doing that, what it lets you do is get rid of all the denominators. Um, I guess that would be a little off though because of this. So it looks like this one's just a weird parabola that has fractions as coefficients. I was hoping it would go away, but then I realized, like, oh, you would still have to divide by 12 again to get rid of that, which is what happened here. So don't do that. Sorry. That was just a weird parabola. Um, all right, and then just talk about what happens when you have directrix. So these are really interesting narratives to read. I'm not going to go through them. You can always go through them on your own if you're having trouble understanding. They do kind of explain, well, what if the directrix was here and stuff like that. All right, so let's get into solving a problem. All right, so write an equation where the focus is this, the directrix is that line. Find the y. So they want this in y equals, is what they're saying. All right, so we're going to do a little bit of work here. I didn't explain how to do it because we're going to do an example of it and we're going to figure it out. But you can go back and read how they wanted you to substitute it. So let's remember this one and x equals. So if x equals something, we're going to be dealing with a vertical parabola whenever we're dealing with x equals for the directrix. If the directrix is x equals, we're dealing with a horizontal parabola. So we're going to do this as y minus h squared equals 4p x minus h. So this is the formula. Remember, we're going to solve for y later. So what we're going to do here is we're going to plug everything in so we get y minus 3 squared equals 4. The distance from this to here will be our p. So if that's a negative 3. So the distance from negative 7 to negative 3 is going to be the distance of 4. And you're supposed to subtract the directrix. So that's how come this works out, because it's -7 minus, -4. That would make it -3. So this is actually a -4. The way I remember if you're supposed to subtract or add to the directrix is think about it this way. A parabola, your directrix is going to be underneath it. So we're going to subtract. So this was -7 minus p equals -3. So the only way to get a -3 would be to add a 4. But since we're subtracting, we're going to subtract the -4. All right, so let me erase all this. All right, and so we get that -4, and then we get h minus, what are we subtracting here for the h? Oh, -7, which I'm just going to turn into a +7. All right, so we're going to end up getting, you can box method this if you like. I kind of have an idea of that it's supposed to be y squared minus 6y plus 9, and that's from negative. This comes from the -3 times y, and then the y times -3 when you're squaring it. Don't think this is y squared plus 9. You're totally forgetting the what I call the oi in FOIL. When you're squaring a binomial, you're foiling. So don't forget that those middle terms. All right, so then we're gonna have -6 equals negative 16 x plus 7. If we want to make this, we're going to have to use a plus or minus here. Use the keyboard to answer the question when done. What equation of parabola is focus here? Directrix is that? This is the focus, not the center. Whoopsie. I just realized this is a focus, not a center. I'm so sorry, guys. It's not that much of a change in work, but it is going to affect our P, and it is definitely going to affect our vertex. So, all right. So the way to picture this is you have negative. I don't know what just happened here. Give me a oh, apparently my keyboard was delayed. Give me a second. All right, guys, I'm gonna have to pause the video because there is a lot of okay. I think it fixed it, but I might have to pause it in a second just because of technical difficulties. I'm sorry, normally I would edit this out, but I don't have editing software. It also takes a lot of time to edit videos. You have to picture this as this is -7, 3, and we're gonna have a parabola here, and we're going to have a vertex or a directrix over here. So that means our vertex has to be smack dab in the middle of this. Since this is x equals -3, that means our vertex must be in the middle of this would be -5, 3. So they tricked me. Be careful when you're reading this. I was so focused on it being the vertex, I didn't even realize that it was a focus. So it does change your formula a little bit. It's not the end of the world, but it did change our formula a bit here. And it is going slow again. I'm going to finish. I might have to finish this video early. Oh, we're so close to being done. We'll see how, you know what? I know what to do. Since this software is going slower, I'm going to use my other pen to do this. Just remember this. because I have to delete it just to kind of clear off the screen. Let's get out of this. And then what I'm going to do is I'm going to use different material here. Are you serious right now? That is terrible. What is going on? Where's the tool? Great. Apparently I am stuck. Give me a second here, guys. All right, I feel silly now because all I had to do was hit escape. I'm going to be using this one because I feel that's going to, it's just going really slow right now. So, as I mentioned before, it is 5, 3 is our vertex. So we're going to do 1 minus 3 quantity squared equals 4. We already said that this, this did change it a little bit. The distance from our vertex to our directrix is a little different now. So now it's going to be -2. And this is going to be h plus 5. So our formula's a little different. Not too far. The one thing that's gonna have me there is a plus or minus here, so never mind. I was a little worried because I was like, well, what do we do? Because there's gonna be a plus or minus option here. All right. So what we're gonna do here is we're gonna do. Let me erase all of this. So we need to foil everything out. I realized while I was on pause trying to fix everything out, I don't have to actually foil this. It's actually not that bad. So this is going to be -8 x plus 5. I'm going to distribute that -8. Oops, hold on. Got a little ahead of myself here. I'm going to distribute that -8 and I get y minus 3 quantity squared equals -8 x plus 5. So then I'm going to end up getting this y minus 3 equals the square root of -8 plus 5. I'm going to divide by -3, so I get y equals negative square root of 8 plus 5 over 3. Now here's the interesting part is because I took a square root, this is plus or minus. So I don't really care that this is -8 or negative square root because I'm still dividing by a negative number. So it's plus or minus this. Almost forgot to have my x here. My x kind of disappeared there. All right. So I'm curious to see if it's going to accept this as an answer because technically it should be an x equals. Now enter the y value coordinate. Okay. Find the y value coordinate. Oh, it just wants this. Oh my gosh. Well, now you know how to solve for the equation. This is what happens when I don't read. I'm sorry, guys. Um, I'd imagine there's a few of you out there who don't like reading as well, so you can see that. I mean, I'm a math teacher, so that's all they wanted us to do was like, hey, what's the value of the vertex here? So a lot easier than I was thinking, but now you guys know how to solve for this and realize like where it is. Okay, so now it wants us to find. Did I skip too far? I did not. Okay, so now it wants us to find the x coordinate of the vertex. Okay, so we need to find the x coordinate of the vertex. So that one, we already did this. That was where I was like, oh, the x is going to be in the middle of the focus and here. So this one was that -5 that I was talking about earlier. So I did actually a lot of work that's going to help us through this next one. So you feel free to rewind if you want to see why that's supposed to be -5. All right, let's take a look at this other one. Write the equation for P. Well, we already solved that. We said it was the distance between the focus and the directrix, or you can even say I'm sorry, it's the distance. The distance between vertex to directrix. That's what our P is. It can also be viewed as the distance from the vertex to the focus. And we said that one was -2. All right, so moving on. All right, so now write the equation. Write the equation for the parabola. Use the keyboard. So now this makes a lot more sense. I was wondering, I was like, but it's going to be in a plus or minus situation because this is a horizontal one, but it looks like they want you to solve for x. That makes significantly more sense, in my opinion. So we're going to write this as y. Remember our hk, our vertex, is -5, 3. So we're going to do y minus 3 quantity squared equals 4 -2 x x plus 5. So a few things we can do here. Since we need to solve for x anyways, we can just basically not even have to distribute that -8 right here. What we can do is just divide by -8. So we get negative y. Oh, shoot. That was not supposed to be a plus. Negative y minus 3 quantity squared all over 8. This is equal to x plus 5. So I'm a little unsure if it's going to accept this. So I'm just going to see if it does. I'm going to subtract the 5 over. So we're going to get this fraction. I'm going to say it is a negative. I'm really curious as to see how picky this is because I have a feeling it's going to want me to expand on this. But me being lazy, I'm going to see what I can get away with here. Oh, control up to 8 minus 5. Let's see if it accepts that. No, it looks like it wants us to expand a little bit more. And it actually gives us what we need to substitute in. So if we expanded this, so we would end up getting, if we expand y minus 3 quantity squared, we get that y squared minus 6y plus 9. We have to remember we're going to subtract the 5. However, before we subtract that 5, we have to deal with dividing by 8. So we get, ugh, give me a second, guys. This is not going to be fun. Or actually, I'll show you guys how to do it, and I'm just going to hit answer. We're going to have to divide by 8 on all of it. And then we have to subtract the 5 from both sides. So this is going to be an interesting fraction. Actually, it's not that bad. Let me solve it. I'm honestly just being lazy. So we're going to get negative y squared over 8. Remember, we're dividing by a negative, plus 6y, which 6y over 8, which 6y over 8, we can actually reduce that to be 3 over 4y. And then we have this, well, 5 would be negative 40 over 8. That's the same thing as 5. So we end up getting minus 31 over 8. I don't want to type in those fractions, so I'm just going to hit the answer button. So you can see here that we have everything the same. What did I do wrong here? It's a positive 9, 40. Oh, they did theirs. It's a positive. It would end up being negative. Oh, because if when we divided by -8, it turned into a negative, so I had to add the 40. Got it. Okay. So I just subtracted when I should have added. All right, let's see what we have here. And then they show us how to do it from the standpoint of a point. So if we have a point in the parabola, we're just substituting that point on the parabola into the x and the y. That's going to help us solve for p. As soon as we have p, we can plug in p and our vertex to get the equation of the parabola, which they're going to do is here. So we have a vertex, we have a focus, and we want it in this given form. Okay. So in order to find this, we need to find P. So P is going to be the distance from the vertex to the focus. That distance, it looks like it's going to be 3 because we're dealing with this 2 going all the way to this -1. So we're going to write P equals 3. All right. Soon as we hit that P equals 3, we're going to plug it into our formula. So let me get into this equation editor right here. So this is, if we look at it, here's our vertex, here's our focus is in here. Because it's a change in y, and the change in y, oh, it went down. So technically I drew this wrong. If I'm looking at the focus and the vertex, I see that I'm at -3 and -3 and +2, and then my focus is down here somewhere. So it's an upside down parabola, but either way, this is a parabola we're used to, so it's going to be an x squared. So we're going to have it as x minus our h. Our h in this case is a -3, so that double negative I erased wasn't technically wrong. 3. I need to square this, control and up to get to the exponent, equals 4, my p. This is actually, because of the position of it, is a -3, because normally you add p to get your focus. In this case, we're subtracting p to get our focus, so our p has to be negative. All right, and then from here, we're going to do y minus our k. Our k is 2, y value of our vertex. All right, so let's do some work in here. They want us to expand it because it looks like they're looking for standard form. So if you expand this, remember whenever you have an exponent, you're not just distributing a squared. You're expanding this by doing FOIL. I'm not going to go over FOIL now, but so I'm just going to write in what the answer is. After practicing this for a bit, sometimes you just kind of get used to it. I've been doing this for years, so it does get easier if you just practice it a lot. All right, so we have this. Now let me distribute everything. Or in this case, I want to solve for y. So instead of distributing, I'm going to divide everything by -12. So I'm going to get negative x control up squared 12 plus, or actually we're dividing by -12, so it's minus, and 6 over 12 reduces. So I'm just going to say that's going to be x over 6. And 9 over 12 would reduce as well. So I'm going to say this is 3 over 4. 3 over 4. I get equals y minus 2 Now I'm going to add 2. 2 is in actuality, if I think about it in terms of 4, is 8 over 4. So I can say this is me being lazy. I'm just going to copy this. You'll see why I'm not copying that last part in a second. If I'm going to add 8 over 4, this ends up being plus 5 over 4. So plus this 5 over 4. I have a y by itself, but I'm going to want to do it this way. So this makes sense for a few reasons. We know that it is an x squared. It was an upside down parabola, so that's why I know my leading coefficient should be negative. And I guess that's it. There's not much else to think about for this one. Let me hit that submit button, and there we go. All right, so let's get into our next question here. All right. So here's our vertex. Here's our directrix. So notice they did not give us our vertex. All right. So if we don't have a vertex, let's kind of figure out what we're doing here. So it's at -5, -5. So we're somewhere over here, and our directrix is x equals -1. So our directrix would be somewhere around here. So that means our parabola is a downward facing parabola, and it's going to be in the middle here somewhere. So if that's the case, the distance between the middle of our vertex and our directrix, I kind of did this in the first video. It's a little confusing then. It's not any better now. We're going to add these two together and divide by 2. So we get -6. When we divide that by 2, we end up getting -3. So that tells me that my focus is going to be -5, comma -3. Did I say focus? I meant to say vertex. All right. So that's going to be our vertex. And what are we doing here? Okay, so what we're going to do here is we're going to plug this in. Oh, actually, first I need to figure out what my P is. And if we notice here, since it's an upside down parabola, my P is going to be negative. So that's a good way to kind of know if it's up parabola or a down facing parabola is what the P is. So this one's down, so it's going to be a negative. And the distance from the vertex to oh, they gave us a vertex? Oh my gosh, guys, I'm so sorry. I'm so used to having to calculate the vertex. Blah. This is the vertex. Well, now you know what would happen if this said focus. I'm sorry, guys. I haven't had my morning coffee today or something, I guess. All right. So that is the focus. Our directrix is above it. So it's still a downward facing parabola. It's just our P is a lot bigger than I thought it was. So the distance from here to here is going to be our P, our focus to our directrix. So it's going to be a -4. All right. So, and I find the directrix a lot more useful because the focus is kind of weird to me. It is important, but I feel it's more direct when it's like, hey, what is your uh, P? Well, P is equal, or I should say, K minus P equals, I guess, D for directrix. That's kind of an easy way of doing it. So in this case, RP is -4. So let me plug in my vertex since we have a vertex now. So again, we're going to do x minus our h, which in this case is +5. You know what? Just to make this easier, I'm going to have the 4 key over here. just because I don't like having to switch the p over later. So I said this was 4. And have y minus k, y minus. It'll make sense in a bit if you guys are like a little lost on what's happening here. Okay, I just want all of this, the 4p times y minus k go here, and then I'm going to have the squared part over here, the x squared part over here. I'm going to multiply this out, so I get negative 16 parentheses y plus 5. I feel this looks a lot nicer too. Now I'm going to expand this, so I'm going to get x squared plus 10x plus 25. So that comes from expanding this, doing FOIL. Then I'm going to end up getting y plus 5. No longer need the parentheses because I'm going to divide 16 from both sides. So, and it's negative x control up 2 over 16. Can't really reduce that. I can reduce 10 over 16. That's going to be 5 over 8. So I get a 5 over 8 x. I couldn't find the x on my keyboard there for some reason. And then I can't really reduce 25 over 16. So it's just going to be 25 over 16. All right, now in order to get rid of that 5, I'm going to be subtracting. So this is going to get even bigger as a negative. 5 and 16. So 5 times 16 is 80. Because 5 times 6 is 30. Carry the 3. We get 80. So we get y equals all the same stuff over here. All this stuff over here. Except now I'm subtracting 80, which since they're both negatives, it's kind of like I'm just adding 80 to that negative 25. So, oops, 105 over 16. I'm just going to leave it as a fraction. Everything else is a fraction. It should be fine. So we get that. Let me see how close I am to the answer. Right on. All right, cool. So be very, very careful when you're reading these. This one actually does say focus. So what I'm going to do is going to be correct this time instead of just rushing through this. I do have a few videos to record. That's why I'm unfortunately not giving this the best quality I can. All right, so I have my focus. I have my, it says the y-axis is the directrix. So it's important to know that y-axis is not y equals 0. It's actually x equals 0. So be careful with that. It is very tricky because think about it. If this is our y-axis right here, it's not where y equals 0. This is y equals 1, y equals 2, y equals 3. Y equals 0 would be the x-axis. So be careful with that. It's very tricky. So we need to find the halfway point between x equals 0 and 2. So that means that our vertex has to be 1 for the x, and the y should be the same as our focus. So it's 1, comma 7 is our focus. Now we can get somewhere. Luckily, this means that the distance from the vertex to the directrix is very easy. It's just off by 1. The directrix is underneath the vertex, so we're dealing with a regular parabola. No need for a negative p here. So let me plug everything in. Hopefully this should start making a little more sense now. So we have 4, 1 for the p. And if you guys want, let me write the original formula. I feel like I keep assuming you guys know it. The formula is 4p parentheses y minus k equals x minus h quantity squared. Oops, forgot to put the parentheses. Quantity squared. I'm going to get 1 for the p, y minus my k is, what's my k here? K is, 7. Derp. Equals x minus my h is 1. Quantity squared. We're looking for standard form. So I'm going to expand this. I'm going to multiply this, which is just 4. Not much expanding there, guys. Equals x quantity or not quantity squared, x squared minus 2x plus 1. Again, what I'm doing is just FOIL. I get a negative x and a negative x in the middle, so I just made it negative 2x just to save time. Now this y minus 7, because I'm dividing all the sides by positive 4 this time. So in this case, I get x quantity, or x squared, keep getting used to saying quantity squared, divided by 4. So it's going to be a very fat parabola because it's being divided by 4. Then I get minus, I can reduce the 2 and the 4 to 1/2. So it's going to be 1/2 of x. And I guess I can kind of do that over here too. I can make this 1/4 x squared, but whatever. I already did it. Plus 1/4. 1/4. Now I have to get rid of that minus 7, which minus 7, we would have to add 7, but since it's a fourth, we're going to multiply 7 by 4. So 28 over 4 is the same thing as positive 7. So that's going to be pretty much the exact same thing, which that gives me the idea to copy this. I'm going to copy it, but I'm going to get rid of this minus 7. I'm going to add it 28 over 4 to both sides. So that means it's 29 over 4. All right, cool. And let me submit this. And then we can see that, what did I do wrong here? Directrix is, x equals 0, not y equals 0. Oh my gosh. Let me fix some letters here, guys. Oh my gosh. I cannot believe I did that. Because it's x equals 0 is the directrix. I literally said don't fall for that trick, and then I did it. Because it's x equals 0 is the directrix, that means that, and I even have it right here too. If I change the focus, it would be 1 for the vertex. So I did that. So let me fix some things here. This is going to be an x. It's going to be an h because we're dealing with a horizontal parabola. Hopefully you guys caught that when I didn't. It's going to be a little different here. So this is going to be x minus 1. It's going to be y minus 7. Going to give me a y negative 14, positive 49. That still stays the same, but this is still going to be the minus 1. This is a y squared. This is a y. This is a minus 1. Dividing this would be 7 over 2 because 14 divided by 4 can be reduced to 7 over 2. This can't really be reduced, so it stays at 49. Um, and it should be negative, so that's correct so far. And then we're going to add. So let me just copy this. Oh, and this should be an x. And then we're going to add that 1, which is 4 over 4. So if we're going to add that 1 to both sides, we're adding 4 over 4, which means this is 53. So you guys can look at this and see how I fixed it. I basically did everything the same except because it's horizontal, it's the opposite way. And honestly, here's the thing with Edmentum, a lot of them, they just copy and paste. This should not be y equals something. This should be x equals. Um, so I apologize for that. That was me trying to rush through this, and I really shouldn't be doing that. All right, so find the equation for the vertical parabola that passes through this point. I'm not going to do this in general form because they're already messing us up by doing this, and they're not asking for it in general form. Let me see. I do have two problems, and I have to get ready for an appointment. So we will actually finish the last two and this in the next video. I was hoping to get it done this video, um, but I want to give it the time it deserves. We all saw what happened here when I rushed and I was just looking at this. So question 3, guys, be careful with it. They have it wrong. I didn't even get to write it the way I wanted it to because I had to fix my mistake. So here it is again. That way you guys don't have to keep pausing and rewinding how to do the work for it. All right. I will see you guys in the next video, which unfortunately I'm probably going to have to get out by tomorrow. Sorry, this video's taking long, or this tutorial is taking longer than I thought it would. All right, guys, have a good one.